Hey everybody, I wanted to give you a little quick lesson on what volume and surface area are, because I think there's been some confusion about those two ideas when it comes to our three-dimensional shapes. So hopefully this will kind of clear up a little bit of confusion you have. Okay, so this is from the Pear Deck. This is slide number 12 in the first assignment from this week, the 911 assignment. So the first thing it asks us is, what is the volume and the surface area? So let's talk about volume first. Volume is basically how much space in 3 dimensions does this shape take up. So if you think of it, each cube, they tell us that each cube is 1 unit cubed. So that is its volume. Volume is a 3-dimensional measurement, so it has length, width, and height. If you think about if I were to fill up the inside of this cube, the amount that it would fill with is the volume. So to figure out the volume of this shape here, since I know each cube is 1 cubic unit of volume, I would just count how many there are. So I've got 1, 2, 3, 4, 5, and then this back here means that there's another stack of 5 behind it, so that gives me 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the volume for this particular solid would be 20 units cubed, because there were 20 blocks that created the volume. Now, what if your solid is not made up of blocks? One of the further questions asks you to find the volume and it's not spaced out in blocks. The easiest way to find the volume of a 3-dimensional shape is you are going to find the area of the base, and then you are going to multiply the area of the base times the height of the base, or height of the solid. Okay, so if I'm looking at this, this is my base here. And that base is an irregular shape, so I would have to find the area just by counting or doing something like that, and then I would multiply it by 5. In this case, the area of each block, each face of the block, has an area of 1 square unit, because area is dimensions squared. So I've got 1, 2, 3, 4, and then I would multiply it by the height, which is 1, 2, 3, 4, 5, and that would give me 20, which is what I got when I just counted them out as well. So this right here, this formula is going to work for any 3-dimensional shape you have. If the base is a triangle, you would find the area of the triangle, doing base times height divided by 2, and then you would multiply it by the height of the solid. If it was a rectangle, you would do length times width, and then multiply it by the height. If it's one of our regular polygons, like we learned back a couple chapters ago, you would find the area of the regular polygon by splitting it up into triangles, finding the area of one triangle and multiplying by how many triangles there are, and then you would multiply it by the height. Remember, the height is always going to be the distance between your two bases. The bases are the top and the bottom, but be careful because sometimes they'll kind of turn your solid on the side, so the bases are the two that are exactly parallel to each other. Okay, now let's talk about surface area. Surface area is kind of the idea of, if I were to dump this into a bucket of paint and pull it out, every part of it that was painted is part of the surface area. So surface area, a lot of times I'll abbreviate it as SA for surface area. The way you find the surface area is you just add up the areas of all surfaces, or all faces. Okay, so if I am looking at this, I'm going to start coloring in all of the parts that would be painted if I were to drop this entire shape into a bucket of paint. Now notice, each of these cubes has 6 sides, but some of the sides would not be painted if you dropped this entire thing in. So when I'm looking at this, I also have to keep in mind that there is a top and a bottom, and then there's also the back side, which I can't see on my paper, but exists if it was in actual 3 dimensions right in front of you. So if I'm going to find the surface area, what I'm going to do is I'm going to count. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Then I need to count the bottom would also match up exactly with this, because in a prism the top and the bottom are the exact same shape. So I was at 29. Then I'm going to add another, if I think of this as being the same as the bottom, it would be 30, 31, 32, 33. Okay, so now I'm at 33. And then if I look over here, this is 2 columns of blocks, so I'm going to have another 10 because there's 5 blocks in each column, and I've got one of those sides showing. So this over here, this entire thing, would be another 10. So I'm going to add that to my 33. Then if I think about this back column, I've got 1 column here, so that would be another 5. I've got another column showing here, so that would be another 5. And then I've got 1 more column showing in the back, so that would be another 5. All right, so my surface area, I had 33 from what I could see. Well, 29 from what I could see, and then another 4 for the bottom. And then I have another 10 from over here, and another 5 plus 5 plus 5, so another 15 over here. So that gives me 33, 43, 53, 58. So the surface area for that would be 58. Now, unfortunately, there's not a quick, easy formula for surface area. For prisms, you're basically going to do the base, the area of each base, and there are going to be 2 bases, so I'm going to multiply that plus times 2, plus the area of each face. Each one of these is called a face. The area of each face added together. So it all depends on what shapes you have. Your faces are always going to be rectangles, so that's kind of helpful. And what you'll find as you start doing more of these is that the height of your prism will be one of the dimensions of the rectangle, and then the perimeter all the way around is going to be, basically, if you were to like cut it up and flatten it up, it would make one big rectangle, and the perimeter would end up giving you that area. So perimeter of base times the height of the prism. That is going to be what's going to get you the surface area of a prism. With the blocks, it seems a little complicated. Once you start doing some shapes, it'll make a little bit more sense, and I'll do some more example videos for you with those.